Alright, Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is FIRDIUZ bin Ibrahim. Alright, I will explain about the fishbone diagram for PCM. So, brainstorming process will be centered on the MATLAB block diagram setting and identifying parameters that affect changes in the output as shown in fishbone diagram. So, for the oversampling and undersampling effect, the output signal while sampling pulse signal, with the major cause being the amount of sampling frequency decided by the equation or defined by our group. Then, the edge and latch parameter have the most impact on the sample and whole block, where the edge controls the direction of the signal, which can be rising, falling, or on either edge, and the latch setting must always be on so that block produce the value of the input from previous time step. Depending on the peak and amount of bits in the system, the encoder produce varied PCM output. The sign and bit order options modify the technique of interpreting PCM output for all converters, whether integer to bit or bit to integer. Depending on the filter type and edge frequency, characteristic in analog filter design can make the signal smoother or rougher. Lastly, the output is also affected by additional block diagrams and amplitude, which suggest further on output signal improvement for PCM.
Assalamualaikum warahmatullahi wabarakatuh. My name is SHAHIRA binti SILMI. So I will explain for part A. So from the modulating signal given, which is 5 sin 2 pi 100t, we can obtain the modulating frequency, which you can get from this equation. We can know that the FM is 100. So the sampling frequency for part A is according to Nyquist. So Fs is equal to 2 FM. So we get the sampling frequency to be 200. And then the period is 1/200. This is the circuit that you have modeled in Simulink. We added more scope, which the first one is because you want to analyze and see the graph after every process, which is the first one is just the modulating signal. Second one is the sampling pulse signal. Third one is sampling process. The fourth one is quantization process. And then the next scope is for the 4-bit PSM data. And then the last one is to see the recovered signal waveform. So we actually also insert one input, which is from the modulating signal, so that we can compare both signal. Okay, this is the circuit in Simulink software. So I'm going to start to run the circuit for 1/200 period for sampling frequency. We have choose 0.02 because one cycle of the modulating signal is 0.01. So to analyze the data, 0.02 should be enough. Okay, after we run, we can see the waveform. Here's this is the 2 cycle of the modulating signal, and the second one is sampling pulse. So from here we can observe that every 1 cycle of the modulating signal, 2 sample is taken. Okay, and then this is the green one is the sampling output waveform, and then the last one is the quantization output waveform, which we get 0 and -1. So we can analyze this 4-bit. So this 4-bit PCM data is represent the quantization value. So the value that we got from this waveform, which is if we can read it, first we get 0, and then we get 0, and then we get -1, and then we get 0. So let's compare it with the PCM data. So I use the cursor selections to make reading easier. So at 0.05, we can read it 4-bit from the top to the bottom. So 0000. Second binary data is also 0000. And then for next one is 1111, and then the last one is 0000. So I have tabulated this data in this table right here. So for the 4-bit, This is the data that I've tabulated in the report. So for the 8-bit PCM data, it will be the same. We just need to change this scope. I will change this to use. Just need to use this scope which has 8 input signal, and then we have to change every number of bits to 8. So for that also I have the result here. So it is read from top to the bottom and then from left to right. So 0, 0, 0, 0, 0, 0, 0, 0, 0. So the data I've also put in the table.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IZHAM FIKRI bin AZIZI. My matrix number is AE18013. Right, I'm going to proceed for the part B. Sampling for MT is more than required according to quiz. Student define your own value, provide only encoded 4 bits. Encoded PCM in the table and scope diagram with their respective quantization interval. Alright, for the scenario 3 and 4, we define our sampling frequency as Fs equal to 2 times 500 Hz equal to 1000 Hz, which is more than 200 Hz based on the scenario given. Okay, next, because of the continuous impulse theater 1 over 1000, so as the period goes, to complete one cycle is 0.01. So the sampling pass taken for this 1 over 1000 is 0.01 second, different from task A. Okay, now we go to the MATLAB. So this is for 4-bit encoded. 4-bit. Here we sampling pass, we change 1 over 1000. Okay, and then next, on here we change the decoder encoder converter to desirable bits, which is 4 bits. Now we see the scope 1. I already run the progress, the circuit. Also, this is the quantization output, and then for the PCM data, here we can read the to tabulate the table with for 4-bit PCM. So this is how we read. So we use the cursor measurement. Then this is 0, 0, 0, 0, and then 0, 1, 0, 0, 0, 1, 1, 1, and so on. Okay. Next, we go to the 8-bit. Same goes to the previous circuit. We change the decoder encoder converter to desirable bit. So this is for 8-bit. Scope 4. Okay, this is the quantization output. Can read the output here based on this cursor measurement. So this is upper than more than 50, which is 98 at 68, and then here 119, then here 123, and so on. So for the bit for scope 4, and then we go for this PCM data for a bit. Same goes to 4-bit. We read like this: 0, 0, 0, 0, 0, 0, 0, and if here 0, 1, 0, 0, 0, 1, 0, 0, and so on. Because of the frequency is more, so the number of samples taken is more accurate than the part A. So which is why we have more data to be tabulated.
Assalamualaikum warahmatullahi wabarakatuh. My name is FATIN FAIQAH binti MOHAMMAD MOHLAS. My metric number is AE1800067, and now I'm going to present to you for part D. So for part D, the initial setting is remain same with the part B, and we're going to see what happened to the recovered message if the if the amplitude of MT is changed to VM is equal to 15 volt and VM is equal to 0.5 volt. So this is the circuit for part D. Basically, this the period 1/1000, which is same with part B. And then for the modulating signal, the amplitude is 15 volt. And then for the encoder, the peak is 15, and for the decoder also we change to peak is 15. So now we're going to run the circuit. And then we're going to see what happened to the recovered message. So this is the modulating signal. The red color is modulating signal, which are 15, and this is the recovered signal, 5, which the value is almost 8. So this is the value. This is the signal after we change the value of VM. So after go through the quantization process, the value for recovered signal will be decreased from compared to the input signal. Now we are going to change the amplitude to 0.5, and then also for decoder, for encoder 0.5, and then for decoder 0.5. Now we're going to run the circuit and going to see what happened to the signal, the recovered signal. Okay, now this is the waveform or the signal when the VM is equal to 0.5. This is the modulating signal, which is 0.5, and then the recovered signal is almost 0.3, which different, or the value is decreased compared to the input signal. From here we can conclude when the system or the circuit is going through the quantization or sampling process, the recovered signal will be lower compared to the input signal.
Okay, so for discussion for part A, B, and C, after we have run and analyzed different sampling frequency for different scenario, we see that the more sampling frequency, the more accurate the waveform to be. It is because there is more sample per one cycle of modulating signal. So for discussion, just to analyze the condensation level, I've set the sampling frequency to be 300 Hz. So the period is 1/300. So we're going to run for 0.02 second. So after we run, so we can actually see a lot of difference from from part A, part B, and part C. So in this experiment, for one cycle there is about 30 samples taken. So the waveform of the quantization is more accurate than for the previous one that my friend have shown. So we can see also for the PCM data, there's a lot more to read. So the way to interpret this data is the same. I'll just run this cursor. So for this one, we have to look at one cycle of sampling frequency. So one cycle of sampling frequency is 1 over 3000, so 0.0033 like that. And then I've also tabulated the data here. So we have about 30 sample taken from one cycle of modulating signal, and then this is the data. So from this data, we can actually know the quantization level used by the MATLAB, the Simulink. So as you can see from the data, I arrange all the binary bit, and then we got for 0 until 7, it follows the binary bits 0, 0, 0, 0, 0, 1, 0, 0, 1, 0 until 0, 1, 1, 1, and then after that it continues at the lowest level, which is at negative 8 with 1000, and up to negative 1 with 1111. So because we use 4 bits, there is 16 levels of quantization level. Okay, so for the recovered signal for 1 over 200, which is for part A, if we observe this waveform is definitely not accurate at all, because the motor signal is at amplitude of 5, but we get negative answers for this, compared to if we do 1 over 3000 as I mentioned earlier, we will get a more accurate recovered signal. So for this, I have to change the fixed step sample time to auto. So you can just run. So as we can see from here, compared from before, the recovered signal we got is around 3 to 4 volt, which is better than before this. It is because there are more sample taken from one cycle, therefore the quantization and sampling process will be more accurate. Therefore the recovered signal also is better than previously. There is a significant amount of decrease in the voltage. That is because of the noise in the quantization process. We know quantization process, if the value is 3.4, it will be rounded off to 3. That's why the recovered voltage will not be exactly the same with the modulating signal voltage. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ELHANIS binti ANUWAR. My metric number is AE1800086. So now I will present the next part, which is part C. Sampling for MT is lower than minimum required according to Nichols. So this is our circuit. So for part C, the sampling frequency need to be set less than 2 FM. That means the sampling frequency must less than 200. So here I have set the period 1 over 100. Okay, now we need to run the circuit. Okay, as we can see the result, the graph, the period of the sine wave can be calculated from the modulating signal, which is 1 over 100. As a result, one cycle of the signal takes 0.01 seconds. And the sampling pulse takes 0.01 seconds to complete one cycle based on the 2 FM sampling frequency. So in the scope 2, it shows the 4 bits pulse code modulation data. And from our observation, the number of sample is too small, and it causes the quantization level cannot be observed or examined. So the output obtained from the quantization level is only has two values, which are 0, 1.
So that's all from me. Thank you.
Alright, now for the conclusion. Finally, utilizing MATLAB simulating software, PCM encoding and decoding has been successfully built and constructed. The development of this PCM encoding and decoding is critical for users and particularly students to have a better understanding. The simulator may also be used by lecturers as an instructional tool to encourage students to enjoy studying and connect it to theoretical viewpoints of electrical communication system. These interactive instructional simulators depiction will aid in a better understanding of PCM, encoding and decoding. Users will be able to grasp the process of waveform display from one to another using this simulator.